Okay, so in the previous video we looked at how we can connect our EV3 robot to our laptop wirelessly using Bluetooth. Now that we've established that wireless connection, we are now going to program a simple series of instructions that will allow us to control our robot using our laptop, and we'll be able to do so on the fly, live, and remotely with no wired connections. And as you can see here, I'm giving you kind of a preview of the program. It's a simple series of instructions that we are going to code. The only difference is that instead of creating numeric constants as we have in the past for programming autonomous robots, we are now programming with controls, and every time we add a control, the control literally gets added here to the front panel, and these are the controls that we will be manipulating to actually navigate our robot and have it do the things that we want it to do. Okay, so now let's proceed to actually looking at how we can create this program. So I'm going to go to New, Virtual Instrument, and I get my two windows. I'm going to tile these up and down. And next I'm going to open my controls palette. Now the controls palette belongs to the front panel. And if I click on the block diagram, I can see my functions palette is activated. If I'm clicked on the front panel, I don't see the functions palette activated. So I have to click on my block diagram panel, and then I can select view functions palette. You'll notice that when I click on the block diagram, I only see now the functions palette. In order to see the controls palette, I have to click on the front panel, and the controls operators appear. That's because each set of instructions belongs to the particular window. Now, the last thing I want to bring up are my tools. They should always be open. Okay, let's jump right into this. Let's go to the MindStore's robotics coding section, and I'm going to start by going to the input outputs, and I'm going to go to the advanced motors, or I'm going to drag in the Lego steering on command. Okay, now I'm going to add some modifiers to this, and you'll notice that there are quite a few connectors here. So let's start with the one in the top center and define the motors that will be connected to this. So I'm going to right click on there and choose create constant, and the first motor that I will choose will be port A. I'm going to add a second motor and add that motor to port B. Next, I'm going to regulate the steering. Okay, so you notice if I take my spool of wire, I could see what each connector is. In this case here, the lower left one, the one on the lowest left corner, is for steering. I'm going to right click on this. I'm going to go to create control, not constant. I want an actual control, a dial that I can manipulate. And you'll notice that that now appears up here in the front panel. And furthermore, I'm going to wire the power connector right over here. Right click on that blue connector that's halfway up on the left side of the steering icon and go to create control. And so again, jumping back to my front panel, you'll notice that we have a steering field and we have a power field with a little knob here to be able to move those numbers up and down. You can also manually type the numbers in. Let me go back to my block diagram. I want this program to run infinitely, so I am going to go back to the top level of my MindStorm's commands and go into the programming and structures, open up structures, and I'm going to grab a loop, and I'm going to loop this. Now let me take my arrow tool, and actually I'm going to hit this little brush tool to clean everything up. Let's select all of this and hit clean up. And there we go, so we can see everything nice and organized. Now this is going to loop endlessly until I need a Boolean operator here, and that will be until the stop button is pushed. So let me right click on this stop command and let's create a control. And there we go. So when the stop button up here is pushed, this loop will stop. Now finally, as my robot is moving forward, backwards, forwards, and steering, I'm actually going to be looking for some tall cones that are about 30 centimeters high and about 10 centimeters wide. And to see those cones, my robot may be placed in the dark. So to see the cones, we're going to use an ultrasonic sensor. So let's go back to the programming, to the top level of the Mindstorm's commands. Go to Input Output, and I'm going to go to Sensor and drag a sensor out here. I'm going to select Read EV3 Ultrasonic in centimeters. There we go. I like my spool of wire because it actually allows me to see which connectors I am hovering over. In this case, I need to say which port I'm going to be on. So I'm going to come over here and say create a control. And so I can choose the port from here, be it port 1, port 2, or whatever. Okay, and then finally, I want a field that will output the number of centimeters, give me a reading on how close my robot is to an object. So I'm going to right click on this lower connector here and choose Create Control. And there we go. We now have a field that will tell us how many centimeters our robot is away from an object. So this is our program. This is the wiring. But it is inextricably connected to the front panel. It's kind of like having a TV set which is wired on the inside, and then you have this screen which is displaying the results of all that wiring. And now I'm going to modify these a bit and create a front panel that is more user friendly. Let me start with the centimeters field. I'm just going to move that over here a bit out of the way, and the port goes with it. So I'll select that. Put those two together. Now finally, the power. I'm going to select the power, move that here. Now I'm going to right click on this, on power, and I'm going to go to the replace menu and go to the number controls, and I'm going to choose a slider. And that will be for my power. And next I'm going to stretch this so it's a little more user friendly and easy to see and manage. Now, our power, we know the power on a robot can go in negatives when it's reversing, positives when it's going forward. And that ranges from negative 100 to positive 100. So we need to change the attributes here because right now we can only go to a positive of power 10. So let's right click on this control and go to Properties, and then go over to the Scale tab, and under Minimum set it to minus 100. And under maximum, put it to plus 100 and click OK. And now our power lever is a little more user friendly. Let's go get the steering now and do the same thing. I'm going to right click on the steering field. I'm going to say replace, go to number controls, and this time I'm going to choose a dial. Click on the dial and scale it up. Move the steering definition right here. Now I'm going to right click on this and choose Properties, and again go to the Scale tab, and in this case to turn completely to the left would be minus 100, to turn completely to the right would be plus 100. So now our dial will allow us to control which direction the robot is steering in. And then finally we have this stop button. We can just leave that as a stop whenever we want to stop the program. Now make sure you've got this set to target to NXT. You hit play, and this program will now start to run. Now currently I'm getting this error message because I don't actually have a robot connected to the Bluetooth. I had disconnected it. So you can always hit Find NXT, and then if you turn your EV3 on and the Bluetooth on EV3 is on, it should find it. You hit connect and things should run accordingly. Now you may find when you're running the script that you need to adjust the steering so that you're turning in small increments, and your power you may have to run at a slower speed because it's not easy. This is not like a remote game controller, so you may want to set your speed at lower levels and you're turning at smaller increments so that you're as precise as possible. Slow and steady wins the race on this one.